Okay, so this last question here, 12, is fun with Maclaurin series. Okay? Maclaurin series are this idea that you can represent a function with a series based on its derivatives. And so the way that a Maclaurin series works is that a function can be represented by f of 0 plus f prime of 0 times x over 1 factorial plus f double prime of 0 times x over 2 factorial dot 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 plus you can continue uh, as many derivatives as you want. So that's like the nth derivative of x with a 0 plugged in times x over n factorial. And the more and more derivatives that you add, the better that the Maclaurin series approximates your function. And this works for nice, smooth sorts of functions. So e to the sine x is our specific example here. So if our function is e to the sine x, then the derivative stays the same because it's an e to the x. But because the inside of the function is itself a function, we have to do the chain rule. So the first derivative looks like that. And then the second derivative, I'm going to go product rule. So f prime means I took the derivative of the first part, times g means there's two copies of cosine x there, plus f, which is e to the sine x, times g prime, the derivative of cosine, is negative sine x. I'm going to go ahead and pull out what they have in common, which is an e to the, oops, something tripped out there, which is an e to the sine x. Then that's multiplied by cosine squared x minus sine x. So it's going to be a little easier to use that version of it. So what do I need to do to find the Maclaurin series? I need to plug in 0 to each of these. Sine of 0 is 0, e to the 0 is 1. So that will pop out to be 1. Same idea, this one comes out to be 1 times 1 because cosine of 0 is 1. What does this end up being? I believe it's again 1 because we have e to the 0 and 1 minus 0. So for part A, the Maclaurin series of f of x up to and including the x squared term. I forgot to put the nth power on that, didn't I? Okay, so our f of x is equal to f of 0, 1, plus f prime of 0, 1, x over 1, factorial, plus f double prime of 0, 1 x squared over 2 factorial. Show that the coefficient, that's part A, show that the coefficient of x cubed in the Maclaurin series for f of x is 0. Okay, so let's do one more derivative here. I'm going to switch colors just so it's a different part of the problem. So I'm going to take the derivative of this part. This will be my f, this will be my g. So the third derivative is going to be e to the sine x times cosine x times the whole brackets, cosine squared x minus sine x, plus the initial part times, let's move this out of the way, the derivative of the brackets, which would be 2 cosine x times negative sine x minus cosine of x. Okay, all of that nice stuff. And so if we plug in 0, a lot of things should disappear here. So if we plug in 0, I'll cross out the pieces that equal 0. Sine of 0 equals 0, sine of 0, sine of 0. This one becomes all 0 there. So what do we have left over? We have 1 all of this right here is equal to 1. And then all of this over here is equal to negative 1. So we really just have 1 minus 1 is equal to 0. Okay? So that's great. Okay, so now let's do part C. Actually, I'll pause it. I'll upload this video. It's already 5 minutes long, and then I'll do part C and D in a separate video.